I'd like to go over the 4.3 quick check. That's not a very hard set of problems, but there are some little tricky things here and there. So we want to look at, acid definitions and some of the properties of acids and things you're just supposed to know and have memorized. We want to practice writing out conjugate acids and bases, and that gets a little bit confusing. And then we're going to do some pH calculations. So over here in the corner, this is some of the results we had when we were testing things with cabbage juice. So notice here that we get red things, we get purple things, greens and blues, and that's the stuff we got with the cabbage. So the first question was just things you're supposed to know about acids and bases. Okay, so the cabbage juice color. So remember with cabbage, okay, the acids were red and pink. And the bases, we had a bigger range. They were blues and greens. But we also got all the way to yellow with the lye. So a really strong base actually turns it yellow. Okay, for the phenolphthalein, okay, this is something you're just supposed to memorize, and that is when an acid is colorless. And when it's a base, it's a nice bright pink. So those are the phenolphthalein colors, and you should just have those known. Okay, Arrhenius definition. So Arrhenius says that an acid is something that increases the H plus ion concentration. So we'll put brackets H plus, so it means the concentration of H plus in moles per liter. And he was saying that a base is something that increases the OH minus concentration. So Arrhenius was really concentrating on H plus and OH minus. Bronsted-Lowry definition is that an acid is something that will donate an H plus, so an H plus donor, and we'll see what that means a little better. And a base is something that's an H plus acceptor. And we're going to find that a lot of times, both of these definitions apply to the same thing. But sometimes, there's the Bronsted-Lowry definition is a little bit broader. It'll take in things that Arrhenius would not consider acid or base. And just a little note, and that is that the H plus is also called a proton. So we might call it a proton donor and a proton acceptor. Hydrogen atom. Okay, hydrogen atom is just a proton surrounded by an electron. And so if we become H plus, all we do is lose the electron. So a proton and a hydrogen ion, those are the same thing. We'll be using that word throughout the course. Now this question here says, for the following identify the acid, base, conjugate acid, and conjugate base. Well, this gets a little bit interesting here. You have to look at something, and you can't always say whether it's an acid or base just by looking at the chemical. You have to look at it in context. So we can see that these two molecules, those are going to change into each other. And let's use these two molecules, different color. We can see that they are related. So the relationship is somebody's going to gain an H plus, somebody's going to lose an H plus. So for this molecule to become this molecule, we can kind of see what it had to do. You had to take away an H plus. So it donated an H plus, so we're going to call that an acid. And this guy is going to be its conjugate base. And then for this other one, in order for NH2 to become NH3 plus, don't worry about the CH3, then this had to accept an H plus. So this is a base, and this is its conjugate acid. And it always works as soon as you identify any one of these things. So if you say, okay, that's my acid, well then if that's the acid, this must be the base. And if that's the base, this guy, since it's related to here, is the conjugate base. And this one is the conjugate acid. So as soon as you get one of those, you can get all four. But again, remember it's in context. You got to see how one thing changes into the other. Now for the next part, it's saying that HSO3 minus is amphoteric, which means it can act as an acid or as a base. So what is its conjugate acid? What is its conjugate base? And the same thing, water. Water is amphoteric as well. It can act as an acid or a base. It can gain an H plus or lose an H plus. So I actually want to jump down to the next question first. So look at number 4. And it says, well, if both of these can gain or lose, then if we put HSO3 minus with H2O, then either the H can go from the HSO3 to the H2O, or it can go the other direction. Okay, either of those things could happen. It turns out one happens more than the other. So if we were saying that HSO3 donates an H plus, this first situation, that means the HSO3 minus is the acid, and then after it has donated, the SO3, the SO3 2 minus, the SO3 2 minus there, that is going to be our conjugate base. So if the HSO3 loses a proton, then what it turns into will be its conjugate base. Okay, now down here, if it's a base, in this case here, it's going to accept a proton. So if it accepts a proton, then it's going to be HSO3 neutral, and so that would be the conjugate acid, because in the reverse, this HSO3 could donate and turn back into HSO3 minus. In the same way, the water, you can see what happens. If it acts as a base, if it gains a proton, it'll become H3O plus, so that would be its conjugate acid. And if H2O is an acid, if it donates, then it becomes OH minus, so this would be the conjugate base. So let's go back up here. So if we have HSO3 minus, and we say, well, what happens what is its conjugate acid? If we're looking for a conjugate acid, that means this must be a base. It must accept an H plus, so our answer is going to be H2SO3. Okay, if this was a base and it accepted H plus, then the conjugate acid would be H2SO3. If this was, if I'm looking for a conjugate base, that means this must be an acid, must be a donor, and if it donates an H plus, then it's going to be SO3 2 minus. So I always go by this word here. If I'm looking for an acid, that means this must have been a base. If I'm looking for a base, then my original thing must be an acid, and that's how I get those two answers. Now we'll try it again for water. So if I'm looking for water, if I'm looking for the conjugate acid, that means this must be a base, an acceptor. So if it accepts an H plus, I'm going to have H3O plus. If I'm looking for a base, that means this must be an acid, a donor, and if it donates, I get OH minus. So you just need to make that make sense for yourself so you can get those kind of answers, because they're really pretty easy. Then down here back on number 4, so we're saying what are the two equations? We can let the HSO3 donate, and if it does, we end up with SO3 2 minus and H3O plus. Or if the H2O donates the H plus, then we end up with H2SO3 and OH minus. Okay, over here to this table about pHs. So the idea was, if you have H plus or OH minus, pH or POH, if you know any one of the four, then you can answer what the other three are. And that's the skill we have to work on. So, if we start off with, we know an H plus, well, we can find the pH, because it's 1 times 10 to the minus 3. We can do that in our head. The pH is 3. Now, officially, it's going to be 3.00. Okay, now, if the pH, we know that pH and POHs always add up to 14. So if we know this is 3, then we know this is 11. Now, we're not going to worry about significant figures. But I am trying to do them correctly. Now, if this is 1 times 10 to the minus 3, then this must be 1 times 10 to the minus 11, okay, because these two numbers here multiply together to be 1 times 10 to the negative 14. Now on our second row here, now we have to kind of use a calculator, okay? So if we say, if I know my OH, then I can find my POH, because all I have to do is take the negative log. So the pH equals the negative log, that's a negative, of the H plus concentration. And in the same way, the POH equals the negative log of the OH minus concentration. So if I take the negative log of this, now you just have to practice with your calculator to make sure you know how to make this work, but it comes out to be 5.09. Now, these add up to be 14, so if I take 14 minus 5.09, I get 8.91. And if I know that this number and this number multiply together to be 1 times 10 to the minus 14, all I do is say 1 times 10 to the minus 14 divided by 8.2 times 10 to the minus 6, and I get 1.2 times 10 to the negative 9. Now on my calculator, when I did that, it actually told me 0.000000001, and I had to put it in scientific notation before I could see the 1.2, so be careful on that. Okay, third row, if this is 11, okay, then the easy one, this must be 3. If this is 11, then I know that my h plus is 1 times 10 to the negative 11, okay, officially 1.0. And this one here would be 1.0 times 10 to the negative 3. That's a 0. Alrighty, next one down, 4.5. So from 14, I know this is going to be 9.5. Now this one I need to use my calculator. So my value for my OH is going to be 10 to the negative 4.5. That's the opposite of log. So I really want to use 10 to the negative 4.5. That's not going to be my answer, though. I have to put it in the calculator and, 10 to the x key. And when I do that, I get 3.16, or I'll make that 3.2 times 10 to the negative 5. And if I do the same thing here, I get 3.16 times 10 to the negative 10. Or I could take this number, divide it into this number, and I'll still get this number. And the last one here says, if I have a neutral, okay, this is the only time where I could actually fill in these other columns because of this last column. If it's neutral, then I know my pH is 7, that's the definition, and my pOH is also 7 because they add up to 14. And this is going to be 1 times 10 to the negative 7, and this is also 1 times 10 to the negative 7. If this said acidic or basic, I wouldn't be able to fill those in. Now, to go back, which is acid and base and neutral. If I want to do acid and base and neutral, I always look at the pH. That's the only thing I look at. And you could do it from anything, but this confuses me, so I only look at pH. So if I have a pH of 3, that's less than 7, so it's an acid. pH 8.91, that's greater than 7, so that's base. pH of 11, definitely base. And 9.5, that's greater than 7, so that's also a base. So I only look at my pH row when I want to figure out whether something is acidic or basic. Now, down below this question, there was one more question, and that was, without using a calculator, and this is a good skill, you should be able to kind of look at a number like this and say, if that's my H plus, what's my pH? And what we want to do, there are some numbers that you can do in your head. So, we can do 1 times 10 to the minus 7. We know the pH is 7. That's easy. So 4.2 times 10 to the negative 7, just lower than that would be 1 times 10 to the negative 7. That makes sense. But if I say, well, what's just higher than 4.2 times 10 to the minus 7? It's going to be 1 times 10 to the negative 6. Now, at first glance, you might think that's 8, because 8 looks like it's larger than 7. But remember, these are negative exponents. So larger than negative 7 is negative 6. So 1 times 10 to the minus 6, so the pH for that would be 6. So we know that our answer here is going to be somewhere between 6 and 7. And anything less than 7, we know is going to be acidic. And that's the quick check.